Have you ever stopped and wondered if the global car industry has been selling the world the same outdated idea for over 100 years? They told us that real power needed a giant engine. They told us that real capability needed a heavy transmission. They told us that true off-road strength needed drive shafts, locking differentials, transfer cases, gears, oil, steel, and endless mechanical complexity. They convinced millions of drivers that the heavier the machine, the stronger it must be. But what if that entire belief system is collapsing right now? Because in 2026, a new generation of electric vehicles is doing something the old industry never expected. It is not just replacing the engine, it is replacing the entire logic of how cars move. And the center of that revolution is China. Today we're breaking down how 4 small electric motors may have just made 100 years of traditional drivetrain engineering outdated, how software is defeating steel, how code is replacing gears, and why honestly the future of driving may belong to whoever controls torque with math instead of metal. Stick around until the end because, well, this shift could totally redefine the auto industry forever. For most of automotive history, the design was pretty simple. You place an engine in the front, the engine creates power. That power goes through a transmission, then through a drive shaft, then into a differential, then through axles, and finally, it reaches the wheels. That system powered the modern world, but you know, it also came with a hidden cost. Every gear creates friction, every shaft adds rotating mass, every fluid system needs maintenance, every moving part loses energy. The more mechanical pieces you add, the more power you waste, before it ever reaches the road. For decades, people accepted this as normal, because honestly, there was no better option. Then came 4-wheel drive systems. These became symbols of strength. SUV commercials showed mountains, mud, rivers, rocks, and adventure. Badges like 4x4 became status symbols. But underneath the marketing was a very complex machine. Transfer cases, multiple differentials, extra shafts, extra weight, higher fuel use, more maintenance, more failure points. Still, consumers believed this was the highest form of capability. Then electric vehicles arrived. At first, many people thought EVs were simply old cars with batteries instead of engines. But that was never the real disruption. The real disruption was power delivery. Electric motors are compact, they are efficient, they deliver instant torque, and most importantly, they can be placed almost anywhere. That opened a new possibility. What if instead of one engine powering all 4 wheels through a maze of metal parts, each wheel had its own motor? No drive shaft, no traditional differential, no gearbox in the old sense, just direct power exactly where it is needed. This is where the game changed. Some companies tried to convert old vehicle platforms into EVs, but others designed from a clean sheet, and many Chinese automakers moved aggressively into that second category. They asked a simple question: if software can control power instantly, why keep outdated mechanical systems? If each wheel can receive independent torque, why depend on old differential designs? If motors are small enough, why not give each wheel its own intelligence? That is the idea behind quad-motor architecture. 4 wheels, 4 motors, 4 independent sources of propulsion. Now imagine what that means in the real world. Your front left wheel can receive one amount of power. Your front right wheel can receive another. Your rear wheels can do something completely different. All at the same time. If the road is slippery on one side, torque shifts instantly. If the rear begins to slide, power can be balanced in just milliseconds. If you enter a sharp corner, the outside wheels can push harder while the inside wheels reduce output. If one wheel is, hanging in the air off-road, the wheel with grip gets the power. This isn't old-school traction control. This is real-time torque intelligence. That is why software matters so much. Traditional systems react after slip begins. Advanced electric systems can predict and adjust before the driver even notices. Sensors monitor wheel speed, steering angle, vehicle rotation, road grip, and throttle demand. Then computers make constant calculations and send torque exactly where needed. This happens incredibly fast. Much faster than any human driver can react, and much faster than heavy mechanical systems can respond. Now, think about emergency scenarios. Imagine driving at highway speed, and suddenly a tire fails. In many traditional vehicles, the car can pull violently to one side. The driver panics, the steering wheel jerks, the risk of rollover increases. But with independent motor control, remaining wheels can instantly compensate. Torque can stabilize the chassis, and the vehicle can remain straighter and more controllable. That is not magic, it is mathematics applied to motion. Off-road driving changes too. People often assume old mechanical four-wheel drive is unbeatable, and in some conditions traditional systems are still excellent, but independent motor systems create new advantages. If three wheels lose traction and only one wheel has grip, power can go directly to that single wheel. No waiting, no mechanical locking process, no wasted energy, just immediate traction where it matters. Mud, sand, rock crawling, steep descents, all can benefit from precise wheel-by-wheel control. So, if this technology is so powerful, why has the old industry moved slowly? Because legacy systems created legacy business models. Factories were built for engines, plants were built for gearboxes, supply chains were built for fuel systems, service networks were built around oil changes and repairs. Entire companies were optimized for mechanical complexity. Changing to software-driven electric platforms is not just a product decision, an identity crisis. Meanwhile, newer players had fewer old systems to protect. That gave them speed. China invested heavily in batteries, power electronics, motor production, semiconductors, manufacturing scale, fast development cycles, and now the results are visible across the global market. This does not mean every traditional company is doomed. Many are adapting, many are building world-class EV platforms, but the competitive rules have changed. Horsepower alone is no longer enough. Now the questions are different. How smart is the control software? How fast is the torquey response? How efficient is the platform? How good is thermal management? How often does the vehicle improve through updates? This is why people say modern cars are becoming computers on wheels, and honestly, that phrase is more true every year. The future car may not be defined by engine sound, it may be defined by code quality. It may not win because of exhaust noise. It may win because it processes data faster. That does not mean mechanical systems disappear overnight. Affordable cars, heavy-duty fleets, remote regions, basic transport markets, these will still use simpler solutions for years. But in premium vehicles, performance machines, intelligent SUVs, and next-generation mobility platforms, independent motors are likely to grow rapidly. Now, just imagine the year 2030. Cars identify grip before the driver even feels it. Each wheel responds independently. Snow mode learns from previous trips. Off-road systems optimize routes in real time. Emergency avoidance begins before panic even starts. Service appointments become software updates. That future is no longer science fiction, it's already forming. So, the biggest question is not whether East or West wins. The real question is who adapts the fastest, who abandons pride, who stops defending outdated systems, who moves from steel thinking to silicon thinking. Because, honestly, the companies that change will survive. And the companies that do not may become history. For 100 years, the car was seen as a machine. Now it's becoming an intelligent platform. Once, wheels obeyed engines. Pretty soon, each wheel may think for itself. Once, drivers fought physics. Now software is beginning to negotiate with it. And, one day, people may walk through museums, looking at old drive shafts, transmissions, and differentials, asking one simple question: did the whole world really depend on all of this? And the answer will be yes. Until four motors changed everything. If you enjoy deep future technology and automotive transformation stories, subscribe now, because the industrial map of the world is being redrawn, and honestly, this is only the beginning.